right. This is an AP Physics 1 student, Marley Bar. I'm here to tell you how to solve a particular wave problem. Okay, so the step for waves are, one, you're going to write your equation, which is F equals V over whatever that symbol is. You're going to adjust the equation depending on what you're solving for, frequency, wavelength, or velocity. You're going to, 3, fill in the equation with your values, and 4, solve the equation for what you are attempting to find. Okay, so this problem here is that there are two strings differing only in length that are attached to the same oscillator as shown in the figure above. Both are fixed to the same end and are under the same tension. The oscillator creates a transverse wave and is adjusted to the lowest frequency that creates a standing wave on the shorter swing. Which of the following explains why there will not be a standing wave on the lower string? A, the waves travel at slightly different speeds on the two strings. B, an oscillator frequency that results in a standing wave on one string of length cannot result in a standing wave on a string of a different length. C, the amplitude of the wave doesn't match the boundary conditions for strings of different length at the same time. Or D, the wavelength associated with the given frequency doesn't match the boundary conditions set by the length of the longer string. Now, we follow the steps for waves to figure out the thing for this equation. One is you're going to write your equation, which is F equals V over symbol, frequency equals velocity over wavelength. Now, I'm given in my problem that all values are equal except for the wavelength, and this is because I'm given the tension is the same for both rows, and the frequency is the same for both, as they're both attached to the same oscillator. Therefore, this means that each of the equations that I set up, I'm going to set up an equation for each string will be the same, except for the wavelength, because one string is longer than the other. And because of the different wavelengths, different types of waves will be created. Since we are told that the shorter wave will be a standing wave, it stands to reason that since the longer wave will not be a standing wave, this is because it is outside of the boundary that create a standing wave as it is longer. So D is the answer, that the wavelength associated with the given frequency doesn't match the boundary conditions as set by the length of the longer string. This is because, as we mentioned earlier, the string is longer than the established standing wave boundary and thus won't be a standing wave. And that's about it. How do I stop recording?